the class. Today's class will be solving a practical problem on velocity time graph, and we'll be examining the JAMB past question as a case study. Let's see this now. This is the diagram, and this is the velocity in meters per second, and time is in seconds. And we have 10 and 5, 10, 20, 30, and 40, and 50. And we are giving the deceleration of the particle. This is the acceleration, constant speed, and the diagram above shows a velocity time graph representing the motion of a car. So find the total distance covered during the acceleration and retardation periods of the motion, and these are the answers. So they are asked to calculate the total distance covered during the acceleration and the retardation parts. So we asked the formula for calculating the distance for the acceleration is half base times height. For the retardation, half base times height. So we start. We have distance for the acceleration part is half base times distance from here to here is 10. Height, distance from here to here, that's 10. So we have 2 here, 1, 2 in 10, 5. So that's 50 meters. So the distance for the retardation of retardation now. Distance from here to here. Distance from here to here is 50. So we can see the distance or the time is done in 10, 10, 10, 10, 10 plus 10, 20, 20 plus 10, 30, 30 plus 10, 40, 40 plus 10, 50. So midway will be 45. The distance from here to here is 5. So 5 times our height is 10. So that will give you 2 here, 1, 2 in 10, 5. So that will be 25. So the total distance for the two now is 50 plus 25. And that's 75 meters. So that's 75 meters. So that's the answer. I hope you have gained something in this video. Bye for now. See you in my next video. Bye.